Good evening. Welcome to today's new session of My Teacher, the biggest classroom of the UAE. So welcome you all for watching this program for today's live session of physics. So those the last week and all we were talking about the concepts mainly focusing for grade 12 students. So this time I thought of taking some contents of grade 11 for those who are doing grade 11, especially in Indian curriculum. You can watch this today's session, and if you have any queries related to physics of grade 11, if you have any confusions, you can very well call us, and you can let's sort out what all problems you've got. But at the very outset, let me tell you, you have opted physics as one of the subjects in grade 11. It means you are supposed to get into a very serious study pattern throughout this year, and of course next year as well. So this time, you know, in grade 11, it's basically a very big leap you had from grade 10 to grade 11 in respect of the vastness of the content. And today I thought of taking some contents at the beginning of your physics portions. So of course a clear background or a foundation is very much required for doing good in physics portion, especially at the beginning. So why I am telling you this is because usually children take it little in a casual approach at the beginning of the sessions, beginning of the academic year, as just after grade 10 you are getting into 11th. But this damages the whole process of your preparations, I will say. Why? Because the very fundamental concepts of physics which are required for you to proceed with the the entire journey through the physics of grade 11 and 12, and even after that also we are doing in grade 11, the first part of grade 11. That means these days, whatever you are doing in the school, you should take them in a very serious way because those are the foundation stones of your physics preparations. Usually you may be having troubles in getting into different contents on a later stage just because of the negligence in part of the preparations at the beginning of your academic year. Especially the content what you call as under mechanics, which is one of the branches in physics. But remember, the contents in mechanics, that's what we are doing throughout, especially in the first term. So the chapter at the beginning, then the one-dimensional motion, two-dimensional motion, laws of motion, work energy power, all these chapters are coming under, even rotational dynamics, all these are coming under mechanics. It's a vast area, and in fact in British curriculum and other such syllabi, they have a separate section for this that is not included along with physics. It is basically coming in mechanics as a separate paper, like along with mathematics and all. You know, it's a different paper. But now in grade 11, the greatest challenge that you have got is you have almost all the branches to study about in physics, of which 11th standard you will be studying more. Your more focus is on mechanics. Remember, the contents of mechanics you should be very clear picture about, and we have lot of questions related to this, especially numerical based questions and applicational questions. If you keep practicing only, you will be able to develop a good command on this subject. That is very sure. So do not be reluctant to get into the numerical problems or the questions of that sort in order to improve in the subject. You know, improving in this subject, there is progress in this subject, mechanics, is very much essential for you to do good in future. Because especially after 12th, when you go for entrance exams and all, many questions you will expect, you need to expect from this section, and which require a lot of practice for you to get into it. So with that note, let me tell you a few things about mechanics. Today, my plan is for you to do certain contents coming in the first part of your 11th standard portions. Basically, you can take this as I should say, you take it as a recap of what you have done in the school in the first term. If any doubts you have on the way, you can very well call us and get them cleared. Okay, so we are here to help you out. Of course, it's not basically a very easy job for you to get a good grip in the subject physics in the grade 11. So the lack of seriousness in this or during this time of your 11th will be reflected throughout your studies. So my appeal to all those who are doing in grade 11 is that take it very seriously this time or these months. Whatever content you are doing, you take it very seriously, then you will be a very comfortable journey throughout your 11th and 12th years. That's what is expected from your the students. So with that, let us get into some areas. See, the first section of the chapter basically leads it refers to the contents like units, dimensions, significant figures, errors. Those all are very, very, very basics of the contents, basics of physics. But again, in that area, some areas already we had done in the previous sessions. Those who have watched the classes the last week as well as the week before that must have noticed that we've been talking about a content which was titled as window to physics, in which I explained some basics of physics, like basic of in fact mathematical background that is required for doing physics. We did about logarithms. I explained about conversion. Okay, all these are the areas which you need to revise well. Okay, conversion, then logarithms. Okay, about the units, about the different types of graphs, all those things which we had mentioned last week. So I want you to revise those areas again clearly. Plus now today I'll brief you something about the first. Let's focus on the first chapter. The first chapter means first chapter coming in the mechanics, that is motion in a straight line. There are two sections, motion in a straight line and motion in a plane. So we'll talk about motion in a straight line first. So in that chapter we have we can say some segments we can divide. First segment, you are talking about we are discussing some definitions related to mechanics. The one-dimensional motion, otherwise straight line motion. Related to mechanics, in the first part we are talking about definitions. Second, we will talk about some equations, right? Third, we will talk about graphs. We will see graphs, various types of graphs and the interpretation of different graphs related to motion. Finally, we will have the numerical problems related to the chapter. So I'll just quickly go through a few contents. As I mentioned at the beginning, in case if you want me to explain something extra, you should call and say that I will be able to help you out. All right. So the very first thing, when you talk about motion, in the definition, one of the terms sometimes you might not have revised well is what you call as the frame of reference. So what do you mean by this term, frame of reference? What do you mean by the term frame of reference? It's easy. Actually, whenever we talk about motion or rest of a body, the very first thing we can say is the motion and rest are purely relative terms. They're relative. So for example, you may say I am now standing at rest. So everyone whoever is around us will say I am at rest. But just imagine you are on the surface of the earth. Earth is moving around the sun. Alright, so in that way the building is moving. We are all in motion. So with respect to our surroundings, when we say, or related to our surroundings, we are at rest. Or you say you are sitting in a bus, a moving bus, and the bus is moving forward, but you see the buildings, trees and all, that is going backwards. So we may say we are at rest, who is sitting inside the bus, we are at rest, all the buildings, trees and all moving backwards. So we may say we are at rest and the building is in motion. That's what I said, motion and rest are relative terms. So to describe motion or rest, therefore, we should have something with respect to which we should say. Meaning, so normally when we say a person is running, we are always relating with or referring to what? What as the reference point? Surface of the earth itself. So earth or the ground is the reference we take to say the person is running or at rest. Right? So a typical example, I'll tell you one more example. See, suppose there is a cow is walking through a grass field, let's say cow. On the top of the cow, a crow is sitting. A crow sitting on the top of the cow and the cow is walking. So a person is standing on the grass field. For the person standing on the grass field, the cow is moving. The crow is also in motion. The crow is in motion, the cow is in motion for a person standing on the ground. What about the cow, or what about the crow with respect to the cow? So for the cow, the crow is at rest, right? The crow is at rest with respect to the cow, whereas the same crow is in motion with respect to a person on the ground. You see, the same time, same object is at rest and in motion. That depends on with respect to what we are relating. Again, in this example about the moving bus, the driver is sitting inside the bus and you are also a passenger inside the bus. So what the picture is? The driver, with respect to the driver, or with respect to you, the driver, or with respect to the bus, the driver is at rest. He is sitting. But for a person standing outside the bus or standing on the road, driver is in motion. The same driver, same time at rest and in motion. That depends on with respect to what we describe the motion or rest. So this object or the thing with respect to which we define rest or motion of a body is what is termed as the term frame of reference. So what is frame of reference in short terms? Or in simple terms, we can define frame of reference as the object with respect to which we describe the rest or motion of a body. See, what is a common frame of reference? Generally, what we say as what we take as a frame of reference, we take the surface of the earth or the earth as the or ground as the frame of reference when we talk about the rest or motion of a body. So once again, what is frame of reference? Frame of reference is that object or the thing with respect to which we define rest or motion of a body, another body. I hope it is clear. Okay. So now the terms like, you must be well familiar with the terms like distance, displacement, speed, velocity, acceleration, uniform velocity, average acceleration, average speed. Okay, average speed is average speed and average acceleration are very important terms with respect to the calculations we consider, or in reference to the calculations. So for example, average speed, if you want to calculate a total distance divided by total time, average speed. Okay, and in uniform accelerated motion, first of all, you just think of two types of motion. One is uniform velocity, second is uniform acceleration. What do you mean by therefore uniform acceleration? For example, you are well familiar with the value 9.8 meter per second squared. The acceleration, we say acceleration due to gravity is 9.8 meter per second squared. So when you talk about the acceleration due to gravity, what do you mean by saying that 9.8 meter per second squared is the acceleration due to gravity? What do you understand from that? We may take it like this: a body, when it is dropped from a height, okay, body dropped from a height, at the beginning its velocity is 0 or speed is 0. So as it comes towards the ground, every second its velocity increases by 9.8 meter per second. So we say 9.8 meter per second per second. is the change in velocity per second, 9.8 meter per second. That's why 9.8 meter per second squared. So every second its velocity keeps on increasing by 9.8 meter per second. Okay, so that is uniformly accelerated motion. But you think of a case, a train, it's going with say 54 kilometer per hour, means what? Every hour it will, so it is going in such a way that every hour it will cover 54 kilometer. So it's a uniform speed, right? If it is in straight line motion, then we can say it's moving with uniform velocity. Basically velocity and speed, if you take into account, they are two. Speed is a scalar quantity, it has no specific direction, whereas velocity, you know that velocity has a specific direction, so it is a vector quantity, right? Now the equations of motion, when we say, I mentioned two situations. One is the body moving with uniform velocity, the other one is body moving with uniform acceleration. For uniform velocity, just remember this equation whenever we deal with, I'm talking about the areas to remember when you discuss the when you come across the numerical problems or application questions related to this chapter. I'm not going in detail about the theory contents of this chapter. I'm just giving a briefing about the basic equations which are useful for doing numerical problems in this chapter, and I'll show you a few examples as well. Okay, so listen. So first thing, we know the equation S, distance S is equal to velocity multiplied by time. So this equation you can use. This is actually, even if it looks a small equation, remember this is a very important equation. Whenever you deal with the cases of objects moving with uniform velocity, we can use this equation. Think of that equation. So when you go through the questions, just see, is it uniform velocity or uniform acceleration? If it is uniform velocity, straight away you think of this equation, you will be able to solve it out. Alright, and the remaining equations, which we call as equations of motion, we have V equals U plus AT, S equals UT plus half AD squared, then V squared equals U squared plus 2AS, and even one more equation, S is equal to U plus V by 2 times T. Okay, and one more, you must have seen this equation, Sn is equal to U plus A times N minus half. Just see all these equations. What's the relevance of all the equations? You can see in all the equations are useful for calculating the different quantities if the object is moving with uniform acceleration. So there is A coming. See, what do these symbols represent, by the way? U stands for initial velocity, A acceleration, V velocity, final velocity, S is the displacement it has got, and T is the time interval. Remember, whenever we have equation or whenever we have a question in which there is no mention of time, time is unknown. Okay, so time without use of time, you can use this equation. So this is the equation you should think of whenever you are given a question in which time is not given. So think of that. So this is one equation which doesn't have time, and this is equation to calculate displacement in terms of this U plus V by 2 alone can be called as average speed or average velocity. U plus V by 2, average velocity multiplied by time is the displacement. Okay, other equations all are useful. By the way, one more thing, this equation, just think of this. Sometimes you might not have seen this equation, some of you might have done already. So where do we use this equation? Sn is equal to U plus A into N minus half. I'll tell you, just think of a situation when an object is dropped from height again. Suppose it reaches the ground in let's say 10 seconds. Okay, so in 10 seconds the object reaches the ground. In every second it covers some distance, first second, then second second, third second, like that if it goes. So it covered total of, say, maybe after 9 seconds. Okay, after 9 seconds, the 10th second it is covering some distance. It will be the largest distance per second, correct? Because it is having accelerated motion. So we say the 10th second alone how much distance it travels. Okay, so we are able to calculate the distance traveled in the full 10 seconds using this equation. But if the question is to calculate the distance traveled in the 10th second of motion, then we could use this equation. You see, this is the relevance of the equation, or this is the importance of the equation. This equation is suitable to calculate the distance traveled by the object, uniformly accelerated object, in the particular second, nth second we say, maybe 10th second or maybe 8th second. So that n is that particular second, 8, and if n is 8, here also 8 will come. So distance traveled by a body in uniformly accelerated motion in a particular second, nth second, is what is calculated using this equation. This is also an important equation for solutions. Now I will show you one or two questions related to this, relevant to this one. It is different type of questions, but after that I will show you some simulations based on the vectors and all. We will come across that, but first let me explain one question from this. That is, it's like a proof question. Okay, listen carefully. See, we have got, this is the question, just listen to the question carefully first. This is a tower. Okay, on the tower or from the top of the tower, initially an object is thrown down. Okay, it is thrown with a speed u. Okay, so u and all we can assume, but the question first let me complete. An object is thrown with a speed down from the top of a tower. It reaches ground in t1 seconds. Alright, and from the same tower it is thrown up with the same velocity. It reaches the ground in t2 seconds, let's say. Again, what the question is, from the same tower, from the top, if the body is dropped means initial velocity is 0, then how much time, or we have to prove that or show that it will reach the ground in root of t1 t2 seconds. Just let's see how you do the question. Once again, let me say the question once again. An object is thrown from the top of a tower, reaches the ground in t1 seconds. Then an object is thrown up, first of all thrown down, reaches the ground in t1 seconds. Another situation, an object is thrown up, it will reach the ground in t2 seconds. In that case, we have to show that when the object is dropped from the same point, from the same tower, top of the same tower, it will reach the ground in root of t1 t2 seconds. You have to prove this. I'll show you how to go ahead. Again, assume the height of the tower as h and the velocity with which it is initially thrown down, then thrown up, same, it's supposed to be the same. Here the initial velocity is 0, the object when dropped down. Now let's see, we are going to use the equation. First of all, which equation you should think of? The equation that contains displacement, acceleration and time. So that equation is nothing but s is equal to ut plus half a d squared. So think of that equation. I am going to use s is equal to ut plus half a d squared. So instead of s, see, it is displacement. Always remember, there is a sign convention also you should apply, sign convention. That means the various quantities, like we have velocity, we have displacement, we have acceleration, all these vector quantities, we should apply appropriate sign. So it's always better to follow, for convenience, otherwise to avoid confusions, it's always better to follow the coordinate system concept. That is, anything upwards you take as positive, anything downwards you take as negative, towards right you take as positive, towards left you take it as negative. So in that context, we can say the acceleration due to gravity, for any object which is accelerated downwards, acceleration due to gravity always downwards. That means acceleration due to gravity is always negative, right? Because it is down. So if a body is thrown up, the velocity is upwards initially, so that is to be taken as positive. So body thrown down, okay, velocity is downwards, take the acceleration as negative. So remember, anything upwards you take as positive, downwards you take as negative. If you apply that convention, remember sometimes this convention you might have done in a different way, just let us follow this now, okay. So you have to stick on to one particular sign convention with respect to these equations, alright. So now the displacement, I am going to use the equation s is equal to ut plus half a d squared, okay. So displacement is negative h here, Why? Because it is downwards. Is equal to u. U is initial velocity. What will be the direction of initial velocity? The initial velocity is thrown down, no? Thrown down means minus u. T1, the time is T1. Half a t squared. A is negative g because acceleration is always downwards. So minus half g T1 squared. So we get h is equal to, taking all the negatives, you can say h is equal to ut1 plus half g T1 squared. Okay, this you take it as equation 1. Right? Then, now the next one. Look at the second situation, second case. Okay, the second case, the equation again. Think of this object is thrown up. Okay, it is going up. Then this object, how it will go up and then come down. Can I say what will be the displacement, actual displacement? So displacement is, see, from here it goes and goes there till it reaches here, displacement becomes 0. Same, coming to the same point. After that, how much? H only is there, and that too downwards. Okay, so we will write the displacement as minus h for the second case, minus h itself because downwards. U is but upwards. U time T2. Acceleration due to gravity always negative. So minus half g T2 squared. So we will write h is equal to, taking the negative, multiplying throughout with the negative, we can rewrite the equation as h is equal to half g T2 squared minus u T2. So this is equation 2. So we got 2 equations. Correct? So all of you have seen these 2 equations. Okay. Now I am going to explain what's happening with the, so before going ahead with the third case, I am going to equate these 2 equations. Okay, that is, the equation is h in the left hand side. Here also h in the left hand side. So just equate these 2. So equating equations 1 and 2, what do we get? Just you may write u T1 plus half g T1 squared is equal to u T2, right? Half g, otherwise first you will write half g T2 squared minus u T2. Okay, so you have seen this equation. Now you collect all the terms that contains u, terms that contain 2. So, u multiplied by T1 plus T2. I have taken this term to the left hand side and this to right hand side. It will become what? Half g multiplied by T2 squared minus T1 squared. Is that clear? T2 squared minus T1 squared. Now that means u multiplied by T1 plus T2 is equal to half g into, now you know the identity a squared minus b squared is a plus b multiplied by a minus b. So T2 plus T1, otherwise T1 plus T2 into T2 minus T1, or T2 plus T1 and T1 minus T2 minus T. So these two are, you can cancel them. Okay, so we will get u is equal to half g into T2 minus T1. This is equation 3. So we got an equation, half g into T2 minus T1 is the u. Okay, we got an equation for initial velocity. Now I will do one thing, I will rub this part. Okay, now I will write it here. Okay, just listen to this. Now we have to take the third case. In the third case, the body is simply dropped. Simply dropped means initial velocity is 0. Initial velocity is 0. Then what will be the equation? It is dropped down. That means minus h is equal to initial velocity is 0. So 0 plus half, again g is negative, g t squared. So again, therefore h is equal to, what you will write is half g t squared. This you may take as equation 4. Okay, half gt squared. Now one more thing, we have half gt squared and we have this this equation. Again you can see here we have h and we have another equation with h. So what I am going to do is just equating equations 4 and 1. Okay, so we get half gt squared is equal to, you write this equation, u t1 plus half g t1 squared. So, I am going to rub the remaining part. Just make sure you understood up to this step. Okay. Now, what we will do is, that is half g t squared is equal to, instead of u, you write this equation. Once again, I will write it here, half g into t squared is equal to, instead of u, from equation 3 I am taking half g t2 minus t1, okay, multiplied by t1 plus half g t1 squared. Got it? That is, I am substituting u in this equation. We are reaching towards the last phase of this answer. So, remember, it's like, it's a different type of question. This is this kind of questions only you have to keep practicing. Now, you see half g can cancel throughout. So, what do we get? T squared is equal to, just multiply this, t1 t2 minus t1 squared plus t1 squared, minus plus cancel off. So, finally, we have reached the destination. We have reached the final answer, that is t is equal to square root of t1 t2. Okay, so we have got the equation. So, what was the question? Listen, what was the question? An object is initially thrown down with a velocity from the top of a tower, reaches ground in t1 seconds. Same object is thrown up from the same tower and reaches the ground in t2 seconds. And if it is dropped from the same tower, how much time it will take? You to prove that it takes time, root of t1 t2 seconds. That was a question given. So, the equation which we used is s is equal to et plus half a t squared. Remember, a point where you may go wrong is the case of taking proper sign, appropriate sign is to be taken. Okay. So, I showed you this question and answer. You practice this again, and we will discuss about we will discuss the concepts of vectors now after this. Okay, after a short break. Okay, I will go for a very short break. After the break, we will come back and we will discuss a few more points related to mechanics in grade 11. So, stay tuned, my dear students. We will see after a short break.